Okay, good morning. Welcome to
Family Math number 81.
Can you tell me something that's special about 81?
It's 9 times 9.
It's 9 times 9. Can you think of anything else that's interesting about the number 81?
Well, it's 3 times 27.
Yeah, what else is it 3 times? It's not just a power of 9.
It's a power of 3 too.
Yeah.
3 to the 4th.
It's 3 to the 4th. How fun. All right, so today we're going to talk about a fun puzzle called the Tower of Hanoi. And we're going to go through this kind of quickly, but you can definitely read about the Tower of Hanoi online. The main interesting thing about this puzzle, or the rules of this puzzle, are you have these little discs, and you're trying to move the tower, the whole tower of discs. I wonder if I can do this without spilling it everywhere. Probably 2 hands would be a good idea. Trying to move the whole tower of discs over to a different peg. Actually, and it doesn't matter what peg. And the rule is you can never put a small disc or a bigger disc on top of a smaller disc. So I cannot put this disc on this one or this one. So that when I'm moving here, I have to put this disc on this one first in order to move this. Then I come back over here and move. Okay, makes sense? Mm-hmm. All right, so what we're gonna do is we're gonna count the number of moves required to solve the Tower of Hanoi puzzle. Okay, and we're going to start with the simplest Tower of Hanoi puzzle you could possibly have.
1.
There's 1 tower. Okay, now let's see if we can figure this out. See if you can figure out how many moves it takes to move that tower to another peg. On your marks, get set, go.
1.
1 move. Okay, so peg, discs, moves. 1, 1. Okay. Now,
What about 2?
About 2. All right, do you want to come over here and try to do this?
Yeah.
Come around over by the... Here, I'll spin it around this way.
Alright.
Okay, so you have 2 pegs. Okay, so 1, 2,
3.
3. Okay, so that looks like 3. Okay, now let's try 3 pegs and see what we can do here. Let's see if we can see a pattern. Okay, go ahead. Let's see if we can find the minimum number of moves. 1, 2, 3, 4, 5, 6, 7. Whoa, good job. That is the minimum number of moves. I looked it up. Now, if we didn't know about that, and I hadn't looked it up and I'm trying to do a real quick video, we would have to figure out why that was the minimum, but you did. You found it correctly. So good job. All right. Do you see any pattern with these numbers so far? 1, 3, 7. You see anything that you might think could help you guess what?
Well, this increases by 2. This increases by 4.
Okay, so what do you think this one might increase by?
Maybe 6 or 8.
Ooh, either 6 or 8, because right, it might be 2, 4, 6, or it might be 2, 4, 8 with powers of 2. Oh, did I put the wrong disc on?
Yeah.
Actually, you know what? To make this a little easier to see, let's use the bigger discs. So we get a tower with 4 pegs, but they're just the bigger pegs. Okay.
Right. So.
Do you want to try, or do you want me to try?
I think I can do it.
Okay, go ahead. Let's see.
So if we do 1,
2, 3,
4.
4.
We're gonna have to move this over here.
Yeah.
5,
6,
6,
7,
8.
8. Good job.
And then 9, 10, 11, 12, 13, 14, 15, 16.
Looks like we got off a little bit.
Yeah.
All right, let's see. You want to try? You want to give it a try, or do you want me to try?
Should be 8 or 6.
You want me to try? Let's see. We think we're going to be adding either 8 or 6 here, so that would either be 7 plus 6 is
13. Yeah, and
7 plus 8 is 15. Okay, so let's see what we can do. 1, 2, 3, 4. Now I got to move this peg. So that means I got to 5, 6, 7. Remember how it took 7 moves to move the 3? 8. Now I got to move the 3 over here. How many moves is that going to take?
It's gonna take 7.
So I should get to 15. Let's see if we can do it.
Right.
Okay, I'm at 8 right now. 9, 10, 11. See how I moved this over here? Now I can move that onto there.
Yep.
12. Can you do it now? 13, 14, 15. How interesting. So we added 8.
So to 4, 8. So we should add 16.
Yeah, let's not do that one, but
Yeah.
tell me if you can see a pattern in the numbers other than just adding 2, 4,
Well,
8.
it's
One.
powers of 2.
What do you mean it's powers of 2?
It's
Where are
one,
the...
It's 1 less than powers. It's 1 less than powers of 2.
Ah, how interesting. With 1, this is 1 less than 2. With 3, this is 1 less than what?
It's 1 less than 4.
4.
7 is 1 less than 8. And 15 is 1 less than 16.
And how do these powers of 2,
Well,
2, 4, 8, 16 relate to the number of discs we had?
It's
1, 2, 3, 4.
It's these numbers times 2. Well, actually, it's these 2. It's squared. These 2.
How does 3 relate to 8? How does 4 relate to 16? How does 2 relate to 4? Remember, we're looking at powers of 2 here.
Well, 2 squared is 4.
2 squared is 4.
3 squared minus 1 is 8.
Yeah, but we're looking for powers of 2. 2 squared is 4.
Oh, what about... So, 2 cubed is 8.
Ah, 2 cubed is 8. What about 2 to the 4th?
That's 16.
Haha, look at that cool pattern. And 2 is 2 to the 1. So it's 1 less than the power of 2 that you get from the number of discs. And what's special about this actually is that this is the special version of the Tower of Hanoi that has 3 pegs. The numbers actually change if you use 4 pegs or 5 pegs or 6 pegs. But it's a fun math pattern to try to study. And you can see a really cool pattern. With the Tower of Hanoi, when you count the minimum number of moves it takes, you get 1 less than a power of 2. What do you think the maximum number of moves it would take?
Infinity.
Infinity.
Yeah, because you could just keep doing it.
Ding, 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 ding. All right. Good job, guys. Tower of Hanoi and powers of 2.